Z-scores measure the number of standard deviations a value is above or below the mean. A test is normally distributed with a mean of 72 and a standard deviation of 9. We want to find the Z-score for the following test scores. So 72, that's our mean. So it's neither above the mean or below the mean. So it would have a Z-score of 0. The mean always has a Z-score of 0. But to find the Z-score for other values other than the mean, we have a formula. It's the value minus the mean over the standard deviation. So for a test score of 85, to find the Z-score, it would be 85 minus the mean of 72 divided by a standard deviation of 9. I get 1.444, a bunch of repeating fours. Z-scores are always rounded to 2 decimal places. So get a Z-score of 1.44. What that means is 85 is 1.44 groups of 9 above mean of 72. Now for 60, that's below our mean. Let's find the Z-score for 60 by taking the value minus the mean was 72, divided by our standard deviation of 9. And they see that I get a negative 1.3333 and so on. I'll round it to 2 decimal places, so negative 1.33. That negative Z-score tells us the value is below the mean, which we would expect for 60. 60 is 1.33 groups of our standard deviation, groups of 9, below our mean of 72. Now, a standard normal curve is when all the values are expressed in terms of Z-scores. All the values are expressed in terms of how many groups of our standard deviation the value is above or below the mean. If our values have been converted to Z-scores, we can use tables such as this one to find the area under a standard normal curve. And those areas under the standard normal curve can be converted to percentages. So we can find, using the standard normal curve, the percentage of values that fall within given intervals. Now, our table, it's in 2 parts. It's for positive Z-scores, and there's one for negative Z-scores. So, this table measures the area under the standard normal curve to the left of a given Z-score. So we want to find the area under the standard normal curve to the left of a Z-score of 1.25. So I'll draw my curve. All right, the mean goes right in the middle. That's a Z-score of 0. 1.25, it's more than the mean, so it's going to be to the right. Now, so I want the area to the left of that. Well, that's what our table will give us. So all I have to do, under Z, find the whole number in the tenths. So under Z, go down to 1.2. Now for the hundredths, I have to find that across the top, 5 hundredths. So where they intersect at 0.8944. What that means is the area to the left of the Z-score we looked up is 0.8944. So I could say that 89.44 percent of the data are below values that have a z-score, the value that has a z-score of 1.25. So if we wanted to find the area under the standard normal curve to the right of z equals 0.58, well, let's draw my curve. So right in the middle, that's our mean, and that has a z-score of 0. So 0.58 is positive, so it goes to the right. And what I want is the area to the right of that. But my table only gives the area to the left. I'll take it. That's all I can get. That's what I'll take. So I'll look it up. Whole number in the tenths under z. So under z, I'll go down to 0.5. For the hundredths, I have to find that across the top. 800ths. Now, where those values intersect, that's the area to the left of the z-score we looked up. Well, it's not the area we want. I want the area to the right. So I'll take the whole area. Well, the curve represents 100% of our data. So it's a decimal. Write it as 1. So if I take the whole area and subtract that part I found from the table, that's the part I don't want. I'll be left with the shaded area. So I'll take 1.00 minus 0.7190. So I'll add a couple more zeros so I can subtract. And I get 0.2810. So as a percentage, I could say that 28.10% of the data is higher than a value that has a z-score of 0.58. Now, if I wanted to find the area under that standard normal curve between two z-scores. Okay, so z-score of a negative 2.75, it's to the left. And 1.00, that's positive to the right. I want to find the area between these two z-scores. Well, the best I can do is the area to the left. Now, this is a negative 2.75. So on the table with the negative z-scores, I'll go down to negative 2.7, the whole number in the tenths, negative 2.7. That's here. Now, for the hundredths, I have to go across the top. That's 500ths. Now, where these values intersect, they intersect at 0.0030. The area from the table measures the area to the left of the z-score we looked up. Now, for 1.00, I have to go to the table for positive z-scores. So 1.00, the whole number in the tenths under z, 0 hundredths. So where they intersect, it's 8413. The area from the table measures the area to the left of the z-score we looked up. So to find the shaded area, I'll take the larger area, that's at 0.8413, and I'll subtract the smaller area, 0.0030. And I get 0.8383. So what I could say is, as a percentage, 83.83% of the data will be between values that have z-scores of a negative 2.75 and 1.00.